What if the future of space travel doesn't follow the usual path around Earth's equator, but instead cuts directly over the poles? Right now, a daring mission called FRAM-2 is doing just that, the first crewed polar orbit in human history. And it's not just a new way to fly. It might change how we explore, survive, and even live beyond Earth. After years researching cosmic frontiers, I can tell you, this mission is truly different. For decades, space missions have taken familiar routes, circling Earth along the equator, following predictable paths. But what if those routes are limiting us? What if, by only going sideways, we're missing something above and below? Think about it. Our planet spins beneath satellites and space stations that rarely see the poles. Entire regions of Earth, cloaked in auroras and magnetism, remain virtually unexplored by human eyes from space. Now, picture a ship slicing vertically across the planet, from the icy north to the frozen south. That's the path FRAM-2 is taking. But it's not a government-backed operation or a traditional astronaut crew. It's an unusual team. An entrepreneur, a polar explorer, and scientists, risking everything on a mission that could break ground for all of us. They're not just flying differently, they're thinking differently. And in doing so, they might reveal things we've never seen. In this video, we'll explore why FRAM-2's polar orbit isn't just a bold maneuver. It's a gateway to untapped cosmic knowledge. We'll look at how this mission could unlock secrets hidden in Earth's magnetic field, why they're performing the first ever X-ray in space, and what it means to grow mushrooms aboard a spacecraft. We'll also uncover how surviving this harsh orbit could help us build future space stations, prepare for Martian colonies, and maybe even understand how life began. This isn't just about orbiting differently, it's about thinking differently, and that changes everything. Until now, no human had ever flown in a true polar orbit. Satellites do it all the time, but for people, the risks were considered too great, the logistics too complex, but FRAM-2 changed that. Launched by SpaceX, this mission sends a fully crewed capsule on a trajectory that passes directly over both the North and South Poles, something that's never been attempted by a manned spacecraft. Why is that a big deal? Because it opens up 100% coverage of Earth from orbit. Traditional orbits miss the poles entirely. With polar orbit, every square inch of the planet is visible across each pass. The mission isn't just symbolic, it's functional, it's scientific, and it's strategic. And it's being led not by a government, but by private explorers. Chun Wang, a billionaire entrepreneur, and Jannica Mikkelsen, an adventurer and filmmaker. It's the first time in history a crew like this has attempted something so bold, pushing the edge of what's possible, and reshaping how we think about who gets to explore space. So why take the risk of flying over the poles at all? Because a polar orbit offers something no other path can. A complete view of Earth. As the planet spins beneath the spacecraft, each pass sweeps over a different section, eventually covering every part of the globe, including regions the International Space Station never sees. This orbit is especially valuable for studying climate change, polar ice patterns, and atmospheric dynamics. Instruments on board can capture data from remote, often inaccessible parts of the world, giving us a far more complete understanding of Earth's behavior. It's also a gold mine for observing space weather, the solar radiation and magnetic energy that bombard the polar regions. These phenomena can disrupt satellites, power grids, and even airline communication. But they can also reveal how our planet interacts with cosmic forces. And if we ever want to build permanent stations orbiting for planetary monitoring or planetary defense, polar orbit is the best vantage point we have. FRAM-2 isn't just a cool new route. It's the beginning of a smarter way to explore Earth from above. The poles aren't just cold. They're electromagnetically alive. Earth's magnetic field emerges from its molten core and stretches far into space, forming a protective bubble called the magnetosphere. And guess where this invisible force is strongest, wildest, and least understood? Right over the poles. As the FRAM-2 crew passes through these high-latitude regions, they'll experience direct exposure to charged particles from the sun. These particles are what light up the sky as auroras, but they also carry powerful energy that can damage electronics, disrupt navigation, and even alter human biology. Studying this environment up close is something humans have never done before in real time. Instruments onboard FRAM-2 will measure fluctuations in radiation, magnetic field strength, and particle density, all of which could help us understand how Earth protects life from the harshness of space. And there's more. These extreme conditions might echo what early Earth looked like. Some scientists believe magnetic chaos and cosmic radiation played a key role in the origins of life. If so, the poles might be more than dangerous. They might be primordial. Yes, they're growing mushrooms in space, specifically oyster mushrooms aboard FRAM-2. And no, it's not just a quirky experiment. These fungi are being tested as part of a larger vision for sustainable life support systems in space. Mushrooms can do a lot more than grow on pizza toppings. They can break down waste, recycle carbon dioxide, and even filter water. They're compact, resilient, and surprisingly nutritious. In the closed, high-risk environment of a space capsule, or one day, a Mars colony, mushrooms could become a key player in keeping astronauts alive. Think of them as miniature biosphere assistants, able to turn scraps and CO2 into food and clean air. FRAM-2's attempt to grow them in microgravity isn't just symbolic. It's a test for future survival. If these mushrooms thrive up there, it could change how we think about building self-sufficient life beyond Earth. This experiment might look simple, but it's answering a question as big as the stars. Can we truly grow life, with life, in the vacuum of space? For the first time in history, an X-ray will be performed in space on a human. Why does that matter? Because it's the start of something much bigger. Space medicine becoming self-reliant. Until now, astronauts have depended on Earth for diagnosis and care. But what happens when we go farther, beyond the moon, to Mars, or even deep space? We can't wait hours or days to send scans home and get a response. We need to detect problems on the spot, in real time. FRAM-2 is testing whether we can do just that. This simple X-ray, done aboard a polar orbiting capsule, is a proof of concept. Can our tools, tech, and procedures work in microgravity, under radiation, and without traditional medical infrastructure? If it works, it could lead to portable diagnostic stations in orbit, space hospitals, and even AI-assisted healthcare on other planets. In other words, this isn't just a scan. It's a leap forward in survival, not just in space, but wherever humans go next. Flying in a polar orbit isn't just a different path, it's a more dangerous one. Unlike traditional orbits, which stay in relatively stable zones, a polar orbit takes you directly through regions of intense radiation and temperature extremes. When the FRAM-2 crew crosses over the poles, they're exposed to higher levels of cosmic rays and solar particles, and the spacecraft spends longer periods out of range of sunlight, and sometimes even ground communication. That means more risk of equipment failure, life support strain, and human fatigue. It's a brutal test of what a spacecraft, and its crew, can handle when things aren't ideal. But this is exactly why the mission is so valuable. These stress tests simulate the kind of challenges we'll face during long-duration missions to the Moon, Mars, or beyond. If FRAM-2 systems hold up under polar orbit conditions, they might hold up in deep space too. It's not just a detour, it's a simulation of the future. One where we can't count on perfect orbit windows, and survival depends on robust design and human resilience. One of the most profound angles of the FRAM-2 mission lies not just in where they're going, but in what they're passing through. As the spacecraft orbits over Earth's poles, it cuts through regions bombarded by intense cosmic radiation, solar particles, and magnetic storms, conditions far more extreme than those found in typical low Earth orbit. But here's the mind-bending part. Some scientists believe these kinds of energy fields might resemble the early environment of our planet before life began. Radiation often sounds destructive, and it is. But in the right doses, with the right chemistry, it may have helped kickstart the very first organic molecules billions of years ago. By flying humans through these regions and studying their effects, FRAM2 isn't just gathering radiation data. It's potentially revealing how complex chemistry emerges from chaos. It's like peeking into the ancient lab where life's first spark might have ignited. In a strange way, orbiting the poles could be orbiting the very blueprint of creation, a cosmic echo of how life may have begun. Not just here, but maybe anywhere. FRAM2 isn't just making history. It may be laying the foundation for the next era of orbital infrastructure. Imagine this: a permanent space station in a polar orbit, one that passes over every part of the planet, from the Arctic to Antarctica, gathering real-time data on weather, climate, seismic activity, even tracking wildfires and natural disasters in remote regions where equatorial orbits fall short. Such a station would be a global eye in the sky, constantly moving over different time zones, cultures, and continents. It could revolutionize Earth monitoring, planetary defense, and even provide better communications for polar regions where satellite coverage is often weak. FRAM2 is the first step in proving this is possible. Its path, data, and stress testing could inform how we design, power, and protect future stations from radiation and orbital instability. In a few years, we may look back on this mission as the prototype, not just for exploration, but for a new class of space infrastructure that orbits Earth with unmatched perspective and purpose. Every so often, a mission comes along that's more than just science. It's a statement. FRAM2 is one of those moments. It's not backed by a space agency with endless funding. It doesn't have a crew of decorated astronauts. Instead, it's led by dreamers, explorers, and risk-takers. People who simply believed there was more to see if we changed our perspective. Literally. They're orbiting the planet in a way no one ever has. Flying over poles where Earth's magnetic pulse dances like a living entity. Testing medicine and food in the vacuum of space. And doing it all not because they had to, but because they wanted to explore. And that's what makes this mission so deeply human. FRAM2 Oblast. Thanathurs reminds us that we don't need to wait for the perfect moment or the perfect funding to move forward. Curiosity doesn't ask for permission. It dares, it moves, it orbits differently. In a universe full of unknowns, FRAM2 is proof that the next chapter in human exploration might not be written by governments or institutions, but by anyone brave enough to take the leap and redefine the path forward. If this mission inspired you, if it made you think differently about space, life, or the future, you're exactly where you belong. Here on Boundless Universe, we dive deep into stories just like this. Bold missions, cosmic mysteries, and theories that challenge what we think we know. So if you haven't yet, hit that like button, subscribe, and drop a comment below. What part of the FRAM2 mission fascinates you the most? Let's explore the unknown together. The universe is vast, mysterious, and often silent. But sometimes a single mission speaks volumes. FRAM2 isn't just orbiting Earth, it's orbiting possibility. It reminds us that exploration isn't reserved for the elite or the expected. It's for the curious, the daring, the boundless. So keep asking questions, keep looking up. Because every time we dare to step into the unknown, we get a little closer to understanding what it means to be alive. In a universe with no limits,